To my lab report on modeling the interaction between two charged U-tapes using computational methods and physical principles. In this experiment, we aim to determine how much charge is needed on a U-tape for it to float above another tape using the forces of gravity and electrostatic repulsion. This is a classic example of applying Coulomb's law and Newton's law of gravitation in a real-world setting, with computational modeling aiding in the analysis of the forces involved. According to Coulomb's law, the electric force between 2 point charges is proportional to the product of the charges and then inversely proportional to the square of the distance between them. The gravitational force, on the other hand, is the force that attracts two objects with mass, and it depends on the masses of the objects and the distance between them. According to Coulomb's law, the electric force between the tapes is calculated as this, where K is Coulomb's constant, Q1 and Q2 are the charges on the two tapes, and R is the distance between them. For the gravitational force, we use Newton's law of gravitation, where G is the gravitational constant, m1 and m2 are the masses, and r is the distance between them. In our model, we use the mass of 0.02 kilograms for the tape, and the distance between the tapes was set to 0.03 meters. For the experiments, we used two U-tapes, each with a mass of 0.02 kilograms. The distance between the tapes was 3 centimeters. The charge on each tape was calculated to be approximately 1 microcoulomb. We also found that the electric force between the tapes was 9.99 newtons. We made several assumptions in this model to simplify our calculations. First, we neglected air resistance. We also treated each tape as a point charge, ignoring the charge distribution along the length of the tape. Finally, we assumed that the charges on both tapes were equal and evenly distributed. In my model, I wrote a Python program to calculate the electric and gravitational forces between the two tapes. The key steps included calculating the electric force using Coulomb's law, the gravitational force using Newton's law, and then determining the charge needed on each tape to make the force of repulsion equal to the gravitational force. The program first calculates the electric force between the two tapes by using Coulomb's law. Then it calculates the gravitational force based on the mass and the distance between the tapes. Finally, it calculates the charge required on each tape to produce an electric force strong enough to balance the gravitational force. After setting up the model, I found that each tape needed a charge of approximately 1 microcoulomb to produce a force strong enough to counteract its weight. This charge resulted in an electric force between the tapes of about 9.99 newtons, which is much larger than the gravitational force of 0.1962 newtons acting on the tape. This means the tape should theoretically float according to the model. In comparing the experimental data and the computational model, the results were consistent. The charge calculated using the model closely matched the conditions required for the tapes to float, given the observed gravitational force. Some possible sources of error in this experiment include the assumptions made about charge distribution and ignoring air resistance. In reality, the charge on the tapes may not be perfectly distributed, and air resistance could slightly alter the results, but those effects were deemed negligible for this model. In conclusion, we successfully modeled the interaction between two charged U-tapes and determined the charge necessary to make one tape float above the other. The calculations showed that a charge of approximately 1 microcoulomb on each tape would generate enough electric force to counteract the gravitational force. While this model simplifies the situation by treating the tapes as point charges, it provided a good estimate of the required charge. Finally, I would like to acknowledge the resources and tools used in this experiment, including Glowstick for coding and the lab instructions provided by my course. Thank you for watching.